So the last part of this PowerPoint is going to be focusing on how your body maintains pH. This is something that was discussed before when in the context of your blood and the buffering system of your blood, which is bicarbonate. However, we're going to go into a little bit more detail and discuss this in terms of the buffering system that are also related to the respiratory system as well as urinary system. So, first thing that I want you guys to understand is like any other homeostatic system, your pH is also maintained at certain numbers, and everybody should remember the numbers as ranging between 7.35 to 7.45. Now, anything that goes below the 7.35 is considered to be acidosis, and anything that goes above 7.45 is considered an alkalosis or alkemia scenario. Now, the reason we're discussing this is because these are both considered to be medical conditions. Now, if you look at this in normal, we have the 7.35 to 7.45, which is the green section you see in the middle. Now, that being said, that doesn't mean you will basically die if you go below that. So you go basically into the yellow region. So your blood pH can drop as low as 6.8, and this is basically considered to be an acidosis condition or also known as acidemia. However, if your pH drops below the 6.8, then the body is basically unable to recover from that condition, and that leads to death. Same scenario applies when it goes above the normal range, so basically alkalosis. So your blood pH can go and increase as high as 7.8, which is again dangerous, but the person would be able to survive if it receives treatment. However, anything above 7.8 will cause basically coma and death. Now, how does your body able to maintain this? There are three main chemical buffer systems in your body. The bicarbonate we have discussed before, and we're going to go over it one more time since you guys really need to be comfortable with this. And the other one that I'm going to discuss with you is proteins. Now notice there is a second one, which is a phosphate. There is a slide on this PowerPoint for it. However, I will not focus on it as much as I would do for your bicarbonate and the protein mechanism. So this is your favorite equation that everybody should be very comfortable with, your bicarbonate equation, what we learn about it in the respiratory system. So in this case, you have water combined with carbon dioxide, CO2, and that gives us carbonic acid, which is H2CO3. Carbonic acid, this reaction that is taking place using an enzyme called carbonic anhydrase. Now, when we have carbonic acid in our system, it gets broken down further to form hydrogen ion, H+, and bicarbonate, which is HCO3-, which is your bicarbonate. This is how your body effectively transports about 70% of carbon dioxide from your tissue into your lungs. Now, in addition to that being a very effective system for movement of carbon dioxide, as we keep mentioning, it's also an essential way of your system to be basically buffered and be able to maintain that 7.35 to 7.45. Now, let's discuss this in this term. Again, these two pictures should not be something new to you. Right here, what we have is on the bottom, we have CO2 coming from your tissue, going into your red blood cells. CO2 combining with water becomes carbonic acid, and carbonic acid gets broken down to bicarbonate and hydrogen. When you go back to the lungs, you have the combining of the hydrogen with the bicarbonate, which becomes carbonic acid, and then gets broken down to CO2 and H2O, and CO2 is going to get into your lungs and basically be exhaled. Now, keeping that in mind, we're going to connect this to the whole idea of how, when you are dealing with acidosis versus alkalosis, this reaction is going to be effective. So let's look at the first scenario, which is a scenario where we have, let's say, a blood pH of 7.25. Now, 7.25 is considered to be acidic, or you're dealing with acidosis. That means you have way too much CO2, because CO2 is an acidic component, so you have too much CO2. So If I ask you this scenario and I said you have a blood pH of 7.25, so what happens? How does your respiratory system helps you regain your homeostasis? This is the scenario. So if you have acidosis, the reaction will be shifting into the left-hand side, which means bicarbonate is going to be combined with hydrogen ions. Hydrogen ions is another component that's basically acidic. So you combine these two together to remove the hydrogen ions. Hydrogen ions become carbonic acid and eventually gets changed into CO2. Now CO2 can be basically exhaled out. So if you're dealing with an acidosis situation, 7.25, what happens with your respiration is there is an increase in your respiration with the goal of what? Removing CO2 when CO2 is the acidic component. So the more of the CO2 I remove, that basically the more effectively I can remove the acidic component and return my blood back to normal range. So for this person, they're going to basically hyperventilate. Sorry about the space. So they're going to hyperventilate it, basically remove a lot of carbon dioxide in a very fast, effective way. Now, again, think about this in an opposite scenario where you have a blood pH which is, let's say, is 7.50. This is referred to be as alkemia or alkalosis or alkalemia, if I can spell. So alkalosis, which means you basically don't have enough hydrogen ions in your bloodstream and you want to get more hydrogen ions, which means for that your reaction is going to shift to the right hand side. So shift is to the right hand side, which means your body wants to hold on to the CO2 to convert it to carbonic acid and carbonic acid to release the hydrogen ion. So a person who's dealing with an alkaline blood as a result of either dietary or disease or sickness or medical condition, these people have hypoventilation, hypoventilation, where basically you're going to do what? You wanna decrease CO2 removal, and that way CO2 is going to be eventually converted to hydrogen ions and help with decreasing your blood pH. Now, I want to give you and make sure you understand this. If you are normal, if you are healthy within the range of 7.35 to 7.45, and you start to hypoventilate means you are holding on to your CO2. Hypoventilate means you're not getting rid of your CO2. So if you're holding on to your CO2 means you are going to cause acidosis because you're normal, but you're holding on to an acidic component and therefore your blood pH is going to drop. If you are normal, your blood pH is normal, but you start to hyperventilate, which means you're going to get rid of more CO2, then your acidic component is going to be removed and therefore you become susceptible to alkalosis, which means your blood pH starts to rise. So these are two scenarios I'm describing to you. If you have a medical condition which either causes leads to acidosis and alkalosis, your respiratory system is a very good mechanism to help you return it back to normal. However, if you have a normal blood pH and you start to hyperventilate, that can lead to acidosis and alkalosis because you're either removing too much CO2 or you are holding on to too much CO2. Now, as I mentioned, The phosphate buffer system I'm not going to discuss, so I'm just going to leave it. As you can see, it's kind of grayed out. It is good for you guys to know, but you guys are not going to be tested on. Protein. So if you guys remember, proteins are made up of amino acids, right? And amino acids have this equation, which is, if you draw it properly, you have a COOH group right here, right? Which is the referred to as the carboxyl group, and you have an NH2 group, which is considered to be an amine group or amino group. Now, if you have an acidic environment, acidic blood, an acidic environment, you want to remove your hydrogen ion, because hydrogen ions is what makes something acidic. Now, the way you do that is that extra hydrogen ion is going to combine with what? The amine group. So instead of the amine group being NH2, NH2 becomes what? It changes to NH3 plus. So that extra hydrogen basically gets combined to the amine group, and as a result, that hydrogen is removed from your system, and therefore you can return your blood pH back to normal. However, if you have a basic situation, a basic scenario, or you're suffering from alkalosis, you want to release more hydrogen into your system. You want to release more hydrogen to the system. So for that, you're going to target the hydrogen associated with the carboxyl group. So that case, you want to add hydrogen to your body, to your bloodstream, sorry. And the way you do that is your COOH becomes what? Becomes COO negative plus a hydrogen. And that hydrogen you see here is going to be essential for basically making your blood more acidic and returning it back to homeostasis. So if I ask you under acidic condition, how does your buffer system for protein works? Under acidic condition, you change NH2 to NH3, positive or plus. In their basic conditions, you want to add hydrogen, and that hydrogen comes from the carboxyl group, where carboxyl group release the hydrogen associated with COOH, and it becomes COO negative plus a free hydrogen that contributes to making an acidic blood. Here is basically what I was talking about. So respiratory system and renal system are your two main buffering systems. They are relatively slow acting. We talked about the fact that your respiratory system, compared to your buffering system for bicarbonate, respiratory system and renal system are relatively slow. We talked about respiratory system being adjusted by basically controlling the number of breaths you take and the amount of CO2 you're removing. And renal, we talked about it in the sense of your kidney and maintaining blood pH being one of its main functions. Under low pH, the way your body deals with it means if you have way too much hydrogen, right? It's an acidic condition. So your body is going to remove the hydrogen ions, and it's going to reabsorb your bicarbonate, which is the buffering component. And when your body is dealing with an alkaline situation, high blood pH, it's going to remove the bicarbonate, so you don't really need that component anymore, and you're going to increase or help with increasing of reabsorption of your hydrogen ions. And that way you can help maintain your blood pH. Here is basically using that equation or that whole scenario of respiratory and renal system to balance up your blood pH. Notice right here, sorry guys, notice right here we have the CO2 that can basically stays inside, or it can get removed by your lungs. And on this end we have the bicarbonate component and the hydrogen that can basically be adjusted based on what your body needs, either acidic condition by removing the buffering system, or gaining a hydrogen ion when you are alkaline. And that's about it. So thank you.